Welcome to the video, Chapter 5, Triangles and Congruence, Lesson 2, Triangle, Angle, Sum Theorem. By the end of this lesson, we will be able to answer the question, how do we determine unknown angle measures in triangles? This lesson is all about the angle-sum theorem, so let's take a look at what it is. The angle-sum theorem says that the sum of the measures of the angles of a triangle is 180 degrees. And now I'm going to try to explain a little bit about where this comes from. So what I have here is a triangle, and I have labeled the angles in the triangle angle 1, angle 2, and angle 3 using Roman numerals. So what I'm going to do is you'll see that I'm going to take each angle and I'm going to separate it. Okay, I'm just going to fold over my tape so it doesn't get in the way. And then what I can do with each of these angles that are labeled is I can put them next to each other. And actually, let me go ahead and tape them this way. Now, I'm no longer going to have a triangle, but what I will have is, hopefully, wow, if I could tape things properly, I'm going to end up with a straight line. And we all learned several lessons ago at this point that a line has 180 degrees. So because I can take the angles of the triangle and create a line with them, it proves that there are 180 degrees in a triangle. And now that we have a numeric value for the angles inside of the triangle, we can use that to find missing angle measures and x values. So because all three of these angles add to equal 180 degrees, we can set up this equation, simplify it by adding the two angles that we know, and then subtracting that value from 180 to solve for x. So x equals 34 degrees. Of course, in this example, we must not forget that we do know information about lines, and that is that they add up to 180 degrees. So if I'm trying to find the measures of each angle here, especially in this triangle, I'm really missing two angles in the triangle. Well, I can find the first one here using a linear pair relationship. So I can take 180 and subtract 137 to find that this is going to be 43 degrees in here. So this one is 43 degrees. And then I can use the triangle sum theorem to figure out that if this 43 plus 28 and this missing angle add up to 180 degrees, then we can find this missing one. And I will say we don't always have to use algebraic equations for this. We can just add 43 plus 28 together to get 71 degrees, and then just take 180 and subtract the 71 to get 109 degrees for this missing angle right here. So we don't always have to use the algebraic equations and variables to find our missing angle values. However, in problems like this, using variables and equations simply cannot be avoided because there are x's everywhere. So the triangle angle sum theorem says that I can add these three angles together to set them equal to 180, because the three angles in a triangle are adding up to 180 degrees. So once I do that, I can start to simplify by combining my like terms. So 14x plus 10x is 24x. My constant, so I'm going to add 58, subtract 3 to get 55, and add 5 more to get 60. And then I can solve this two-step equation by subtracting 60 from both sides and then dividing both sides by 24 to get x equals 5. And at this point, I'm going to go back and check my question. Does it ask me to find the value for x? And in this case, it does not. It says find the measures of each angle. So what that tells me is that then I have to go back in and plug the 5 in to find these missing angles. So plugging the 5 in, I got 67 degrees, 55 degrees, and then we had the 58. Now I am going to perform just a quick check, and I'm going to add these, and I'm writing this down, but really you don't have to write this down. You just have to enter it into your calculator. Add these three angles together to make sure that they do actually equal 180, so that way you know that your answer is correct. So my final answer is that my angle measures are 55 degrees, 58 degrees, and 67 degrees, and I just put them in numerical order. Those are my 3 angle measures. Setting up the same sort of situation here, I can add my 3 angles together, setting them equal to 180 since they are 3 angles from a triangle, and we can solve for x by simplifying and then dividing. And again, checking to see what the question is asking. It wants the measure of each angle. So because x is 20, I know that this angle measure is straight 20 degrees. Well, 6 times 20 is going to give me 120 degrees, which luckily does match my picture there of obtuse angle. And then 2 times 20 is going to give me 40 degrees. So just doing, again, a quick check, optional check to write down, but you really should be plugging in your calculator, is adding 120 plus 40 plus 20 just to make sure that that does actually equal 180 degrees. And our final answer would be that the 3 angle measures are 20 degrees, 40 degrees, and 120 degrees in this triangle. So theorem 5.2 is just a branch off of the angle sum theorem, that because there are 180 degrees in a triangle, this is going to be specifically about the acute angles left in a right triangle. Well, think about those angles that are left. We have 90 degrees being used because we're specifically looking at a right triangle here. We have 90 degrees being used, so what does that mean about the other 2 angles that are left? Well, if you were thinking that they are complementary, then you'd be correct. The acute angles in a right triangle are complementary, which means that they add to equal 90 degrees. And again, that should make sense because 90 degrees is used up in the right angle, so then there are 90 degrees left in those 2 remaining angles, and we can use that just to really simplify our equation a little bit. So instead of worrying about 4x plus 9 plus 2x minus 3 plus 90 equals 180, we can just say that these 2 sums or angles equal 90 degrees. So then we can simplify this and start solving. And again, it just makes it a faster equation to solve. And then because the question is asking for the measure of each angle, just like in the last problems, we will go back through and we will plug in the x value that we found and simplify to find the actual angle measures. So our final answer is that the degrees are 25 degrees, 65 degrees, and the 90 degree right angle. All right, so let's take a look at what we have in this particular example. We've got 2 triangles. They seem to be connected here. They're created by these 2 lines that are intersecting, and we've got really 3 missing angles here. We know that this one's 105, this one's 41, and this one over here is 90. And what we can actually remember here from previous lessons is that these are vertical angles. So once I find angle 1, I can quickly find angle 2. And the reason why I'm starting with angle 1 first is because in this triangle, I know 2 out of the 3 angles. So I can use the angle sum theorem here to find angle 1, then I can use vertical angles to find angle 2, and then I can use the theorem about 90 degrees left in the right triangle to find angle 3. So that's exactly what I'm going to do. So I found angle 1 and angle 2 to be 34 degrees. I added 105 plus 41 together, subtracted that sum from 180 to get 34 degrees for angle 1. Vertical angles tell me that angle 2 is also 34 degrees, and now I'm going to take 90 and subtract 34 to get angle 3, which is 56 degrees. So the measure of angle 1 is equal to the measure of angle 2, which equals 34 degrees. And I'm just writing it this way so I don't have to write equals 34 so many times. And then the measure of angle 3 equals 56 degrees. So that does not look like a 6. 56 degrees. And that's my final answer with the measures of each angle. So we're going to wrap this up with the equiangular triangle. An equiangular triangle is a triangle in which all 3 angles are congruent. Well, in order for them all to be congruent, but all add up to 180 degrees, then each of those angles has to be 60 degrees. So that's what theorem 5.3 states. The measure of each angle of an equiangular triangle is 60, and that's because the three angles that we don't know, but they are the same, so x plus x plus x, or 3x, equals 180, x equals 60. So each of these angles created is 60 degrees because of the fact that there are 180 degrees in a triangle. And I did want to include the proofs of the last two theorems, really just so you guys can see what proofs look like. And so the statements, how this works is this statement and then the reason with what's given. So it says triangle ABC is a right triangle. That is information that you are given. So I've drawn an example up here, and I had to actually look ahead at this next one. It says angle A is the right angle. So I had to specifically label this right triangle so that angle A is the right angle. So that's the information that's given. You're given this drawing. Well, that means the measure of angle A is 90 degrees because that's the definition of right angles. Measure of angle A plus B plus C is equal to 180 degrees. That's the angle sum theorem. I can take out the measure of angle A and plug in 90 by substitution because it is a right angle. Subtract 90, and then the sum of the two acute angles, that's all I'm left with, is equal to 90 degrees. And that's the proof of the second theorem. So again, these proofs are really just for you to look at, to just kind of read and see if you can understand, and to justify that these aren't just made up properties, that these exist for a reason. And that concludes the second lesson from chapter 5 on triangles and congruence, specifically the triangle angle sum theorem, which states that all triangles have 180 degrees inside. So when we are determining unknown angle measures in triangles, we know that the measures of the angles in a triangle add up to 180 degrees. So we can use that information to find missing pieces.